Hey y'all, this is just some extra practice from um, graphing parabolas in standard form. Do you have to take notes? No. They're available for you though if you want to. So I just have an extra worksheet next to me, so I'm going to keep looking this way to get the problems, but I'm just going to do a couple. So for instance, if I wanted to graph x squared plus 2x minus 5, I have to do those steps again. So I'm going to find the axis of symmetry first. I'm going to do negative b over 2a to find the axis of symmetry. And then in this case, there's no a, so a is 1, b is 2, c is negative 5. So I'm going to do negative 2 over 2 times 1, which is going to be negative 2 over 2, which is negative 1. So then my axis of symmetry is x equals negative 1. Then I plug that back in to find the vertex. So I'm going to do negative 1 squared plus 2 times negative 1 minus 5. So that's 1 minus 2 minus 5, which would be negative 6. So that means that my vertex is at negative 1, negative 6. Negative 1 is still from the axis of symmetry. This is going to be the same number all the way through. And then I also know my y-intercept is c. So that's at 0, negative 5. Those are the three things that I know just from looking at the equation. And then I'm going to graph it. I started out making these kind of far apart over here, but I realized I needed negative 6 on the bottom. So my axis of symmetry is at negative 1. And then my vertex is at negative 1, negative 6. And then my y-intercept is at 0, negative 5. So I already know it's going to be flipped over on this side too. And then because my a value is 1, then my points from the vertex are 1, 1, and 2, 4. This one's my vertex. It's already on there. And this one is also already on there because right now it's that point. So I'm just going to go over 2 and up 4 from the vertex. And then I have those 5 points that I need. 5 makes it a U shape. 3 could be a V, so we kind of start to stick with 5. And there's my graph. Let's do another one. Let's do y equals, I forgot the y equals on the first one. Miss Keen always gets mad at me. Negative x squared plus 3x plus 1. A is negative 1, B is 3, C is 1. It's negative 1 because there's no number there, but it's still negative. So again, I'm going to do negative b over 2a. So I'm going to do negative 3 over 2 times negative 1. This is going to be not a nice number, but that's okay. We're going to stick through it anyways because I chose to do this problem. So that's negative 3 over negative 2, which is 1.5. Then I find my vertex by plugging that in. Negative 1.5 squared plus 3 times 1.5 plus 1. I am going to need my calculator for this, so I'm going to get that out really quick. Because I don't know what 1.5 squared is. Obviously I should. And then I just did the 1.5 squared first because the negative's in front, and so it's separate from the squared. So this is negative 2.25 plus 4.5, yep, plus 1. So then that would be, this together makes 2.25, so plus 1 would be 3.25. How do I graph that, you ask? What a great question. I'm going to find my y-intercept really quick. It's going to be 0, 1. So that's all the stuff I know from my equation. Are these, by the way, going to be this hard normally? No. Normally I really try to make this an even number or a nice number. And so that way when it plugs in, it's not a weird number, but it's fine. I chose this. I didn't preface it ahead of time. That's what happens when I randomly pick problems that I don't like, that I don't know I don't like. So then so 3.25 is going to be 3 up and a little bit extra. So there's my vertex. And then my y-intercept is up at 1. And so it's also over on the other side of this dotted line, right about here. Who knows? Now I'm going to go, because it's a -1, it's going to be 0, 0, 1, -1, 2, -4, because I multiplied my y values by -1. So I start at 0, 0. That's already done. That's the vertex. So then I go over 1, which would be halfway down, and then down 1, which will be down to like 2 and 2.25. Now this is technically enough, but I could also go over 2 and down 4, which would be right around here somewhere. So then I got my whoop, and there's my graph. It still looks like the same shape, right? It should, because it's not stretched out at all. All right, let's do another one. All right, let's do 2x squared plus 4x minus 4. You know all the things right now, so if you want to pause this video right now, you can try this problem on your own, and then you can press play and see how well you did. Or you can keep watching, and we'll do that for the next one. So again, I'm going to do negative b over 2a. So I'm going to do -4 over 2 times 2, which is going to be -1. Oh, such a nice number, thank goodness. And then we're going to plug that back in. So 2 times -1 squared plus 4 times -1 minus 4. The last time I ignored the negative because it was on the outside, it was here. But in this case, the negative is going in, so I don't ignore it. So I do -1 times -1, which is +1. So it's 2 times +1, which is 2, plus 4 times -1, which is -4, minus 4. So I think that's -6. And then my y-intercept is going to be 0, -4. Those are all the things that I know from the numbers. So I'm going to graph that. I don't have the editing chops to like fast forward my videos, but maybe I'll learn that by the end of the year and you'll be so proud of me. So I just pause them instead. So I can pause recordings, but I can't fast forward them on a, I don't know how to do that. So here we're going to put in my axis of symmetry at -1. I'm not doing a super good job of labeling what these are. So this is the axis of symmetry. This and this is the vertex, and then I do label the y-intercept. So at -6, that's where my vertex is. And then my y-intercept's at -4. So I also have one on this side. Now I can tell because this is over 1 and up 2 that it's a stretch of 2, which it tracks. So I'm going to take 0, 0, and it's going to be 1, 2, and it's going to be 2, 8, because I doubled all of my y values. I multiplied them all by 2. So I already have 0, 0, that's my vertex. 1, 2 I already have because that was my y-intercept. So I'm just going to go over 2 and up 8. So let's see, this is 6 down, so this is 6 up, 7, 8. And then it's also on the other side of the axis of symmetry. I almost swore on camera. There's proof of me swearing now. No, I didn't do that. So that's the graph. Let's do one more. We're going to do -3x squared plus 18x. So a is -3. B is 18. I know B is 18 because it's next to the x. And I know that C is 0 because there's no number here. Just as a reminder, when there's no number for A or B, we use 1. If there's no number for C, we use 0. Okay? So same thing. So I'm going to do -18 over 2 times -3. Again, you can pause this and just see if you're right at the end. That would be -18 over -6, which is 3. And then I plug in that 3. This might be kind of too gross to graph. We'll see. -3 times 3 squared plus 18 times 3. So that's 9. And 9 times 3 is -27. And then 18 times 3, I don't know. So I calculated it. It's 54. So if I add those together, that's 27. This is going to be really hard to graph. And then my y-intercept is 0, 0. So what I know is that my graph basically, and I'm gonna sketch this one instead of showing you all the way, starts here, and then it goes way up here, and then it comes back down again. Is that enough to actually call it a graph? No, I would call this a sketch. But because it's super far off the graph, And I probably wouldn't give you this kind of question normally. We're going to call it good. Don't stress about it. So this is, but I'm going to label it because I know the actual points. There we go. So that way I can at least show you on the graph that I know what the points are. So hopefully that helped you more than just me doing one problem. We also can, by the way, find all the parts that we found before. So in all of these problems, I can find the x-intercepts mostly. Actually, none of them are nice, but I could estimate them. It's like here and here, here and here. And then all of these I can say that all of them have a domain where x is an element of the real number system, or x is all real numbers, because that's just the case for all of these problems. Don't even have to worry about that. And then for this one, my range is that y is more than or equal to -6. My range here is that y is less than or equal to 3. My range here is that y, 3.25. That's right, because it's this number. This one right here is that y is more than or equal to -6. And this one is that y is less than or equal to 27. So those are all my ranges. And then I can also find the increasing and decreasing intervals, right? So it's going up until a certain point and it's going down after that, or it's going down until a certain point and then it's going up after that. So that's how we do those things here. That might be a different video for a different time, but I really do hope that helped. If it did help, please email me so I'll keep doing these. And if it didn't, please email me so I can change what I'm doing to help you. I don't want to do these if it doesn't help. So I will see you whenever I see you next. Okay, bye.